linear equations, functions, zeros, and their applications. Let's get started with talking about the solving principle using the addition and the multiplication principle if we're going to solve for an equation. Notice in our first example we have 3/4 x minus 1 is equal to 7/5. I'm going to eliminate my fractions by using the least common denominator of 4 and 5, which we know is 20. Then I'm going to multiply the entire equation by 20 so that I can eliminate those fractions. When I distribute 20 through, we have 20 times 3/4 x minus 20 times 1 equal to 20 times 7/5. This then provides us with 15x minus 20 is 28. Adding 20 to both sides, we now have 15x equal to 48. Divide both sides by 15 provides us with x equals 48/15, or when we reduce, x equals 16/5. Now that we have our solution, it's important that we check our answer by placing what we think is our solution back into the original equation just to double check. So is 3/4 times 16/5 minus 1 equivalent to 7/5? When I multiply my fractions and reduce, and then I find a common denominator so that I can subtract 1, I see that in fact 7/5 does equal 7/5, so our solution is true and in fact 16/5. Let's try another example. 2 times the quantity 5 minus 3x is equal to 8 minus 3 times the quantity x plus 2. We'll first go ahead and multiply so we can get rid of our distribute, so we can eliminate our parentheses. 2 times 5 is 10, 2 times negative 3 is negative 6x equal to 8 minus 3x minus 6. Combining like terms on the right gives me 2 minus 3x. I now need to get all of my x's together, so I'm going to add 6x to both sides so that I'm left with 10 on the left, and now I have positive 3x on the right. I'm now going to subtract 2 from both sides so that I can get all of my whole numbers together. I now have 8 is equal to 3x. When I divide each side by 3, I see that 8/3 is equal to x. But of course, we have to check to make sure this is a correct solution. So wherever I see x, I'm going to replace it with 8/3. Multiplying first in the inside here will give me 5 minus 8. 5 minus 8 is negative 3. Multiplied by 2 is negative 6. On the right-hand side, I'll first need to find a common denominator. So 6/3 plus 8/3 is 14/3. When I multiply by 3, our numerator and denominator here reduce, giving me 8 minus 14, which is also negative 6. Again, we created a true statement, so our solution is in fact 8/3. Let's solve negative 24x plus 7 equals 17 minus 24x. We'll first go ahead and add 24x to both sides so that we can get all of our x's together. But when I do that, I notice that my x's disappear and all I have left is 7 equals 17. We know that this is not a true statement, so this has no solution. Finally, I have 3 minus 1/3 x equals negative 1/3 x plus 3. I'm going to go ahead and add 1/3 x to both sides so that I can get all of my x's together. When I do that, I end up with 3 equals 3 since our x values end up canceling themselves out. This is a true equation. This means that we have an infinite number of solutions in the entire solution set from negative infinity to positive infinity. Companies in China purchased 36,560 industrial robots in 2013. This is 54% more than the number of industrial robots purchased by companies in the U.S. How many industrial robots were purchased by companies in the U.S. in 2013? So we're going to familiarize ourselves with this problem first, kind of take a little bit of a guess. Suppose that the U.S. companies purchased 20,000 industrial robots. Then the number of robots purchased by a Chinese company could be represented with the amount of 20,000 plus 54% of 20,000, or 1 and 54 hundredths times 20,000. That would give us 30,800. But we know that Chinese companies bought 36,560 robots. They're telling us that. So our estimate of 20,000 that the US purchased is slightly too low. So let's create an equation here. Let's let X represent the number of industrial robots purchased by US companies. That would mean then that 1 and 54 hundredths X represents those that are purchased in China. So let's translate this. We have our equation of 1 and 54 hundredths times X equal to what we know was purchased in China. So let's go ahead and simplify so that we can solve. We need to divide both sides by 1 and 54 hundredths, which is approximately 23,740. So slightly more than our original guess, which we knew what that would be. Let's check. So 54% of what we knew, which was 36,560, is approximately 12,820. If we were to add the 12,820 plus the 23,740 robots, our answer would be 36,560, and this certainly checks out with what we knew. So the companies in the United States purchased approximately 23,740 industrial robots in 2013. In 2012 and 13 school year, 47,058 U.S. students studied abroad in Italy and in France. There were 12,638 more students studying Italy than in France. Find the number of U.S. students studying abroad in Italy and in France. So let's say that X represents the number of students, U.S. students in France. That would mean then that X plus 12,638 would be those who are studying in Italy. Since those who are studying in Italy was 12,638 more than France, and since France equals X, we would need X plus 12,638 to represent those in Italy. Translating then, X plus 12,638 would be our total number of students of 47,058. Let's combine like terms to give us 2X plus 12,638 is 47,058. Subtract the 12,000 from both sides provides us with 2X is 34,420. Divide both sides by 2. We now have X is equal to 17,210. Again, X represents the number of students who are studying in France. So if this is the number of students studying in France, I then can take this 17,210 and plug in for this X here so that we can find out who is studying in Italy. So when I take 17,210 plus the 12,638, which we knew from our equation up above, we get 29,848 would be the ones who are studying in Italy. If we add all of them together, we see that it equals the total amount of students, so we double checked our work. And finally, we can say that there were 17,210 students studying in France and 29,848 studying in Italy. Distance motion formula. The distance traveled by an object moving at a rate in time given by distance equals rate times time. Delta Airlines fleet includes 737, each with a cruising speed of 517 miles per hour, and a 340 with a cruising speed of 290 miles per hour. Suppose that a 340 takes off and travels at its cruising speed. An hour later, a 737 takes off and follows the same route, traveling at its cruising speed. How long will it take the 737 to overtake the 340? Well, clearly the 737 is traveling faster, so it might not take very long for that to happen. So let's talk about the problem itself. Let's let t equal time for the 737. And t plus 1 equals how long that the 340 has been in the air. So it is because I add the plus 1, it's because it says an hour later the 737 takes off. So whatever time that the 737 is in the air, the 340 has been in the air 1 hour longer, which is why I'm having the plus 1 for time. So I have my equation here, distance equals rate or time times rate. I have this little table that I recommend you setting up also in your lesson so that you can easily organize your data. I know that they're traveling the same amount of distance. One is just taking time longer than the other. And we do know that the rate at which they're traveling is 517 miles per hour and then 290 miles per hour. When I set the equations up, I see d is equal to 517t and d is equal to 290 times t plus 1. Once one airplane overtakes the other, we do know that they will have been in the air an equal amount of distance. So they're traveling the same amount of distance, except one is traveling longer than the other. So when I set this equation up, notice that I have 517t is equal to 290 times t plus 1 because the distance with which they are traveling in the air is the same. Now that I have one equation with one variable here, I can go ahead and distribute my 290, providing us with 517t equals 290t plus 290. When I subtract 290t from both sides, we see we end up with 227t equals 290. Now when I divide by 227, I get approximately 1.28. Now that I know that the 737 is in the air for about 1.28 hours, I can find out how long the 340 has been in the air by adding 1 to it. Therefore, if I take 1.28 and I add 1 to it, we have 2.28 hours. This tells us then that the 737's distance that it has been traveling is approximately 517 miles per hour times 1.28 hours for a total distance of 661.76 miles. Similarly, for the 340, 290 times 2.28 hours is approximately 661.2 miles. Since they are about the same, we can say that the answer checks out because we did round here, which is what's providing for the slight difference. Therefore, after about 1.28 hours after the 737 has taken off, it will overtake the 340. The simple interest formula, simple interest I on a principal P, the amount that we're investing at a rate R for T years, is given by interest equals principal times rate times time. Again, where T has to be in years. Demarion's 2 student loans total $28,000. He has one loan at a simple interest rate of 5% and the other at a simple interest rate of 3%. After 1 year, our time is going to be 1. Demarion owes $1,040 in interest. What is the amount of each loan? I'm going to set up a table just like I did for the last one, where principal times rate times time equals interest. So I'm going to look at my 5% loan. We don't know how much that Demarion put in the 5% loan, so we're going to label that as X. We do know that the rate at which it's in the 5% loan is at 0.05, and the time at which it's in that loan is for 1 year. So when I multiply all the way across, our interest then is equal to 0.05x. When I look at the 3% loan, we also don't know how much money that we put in the 3% loan. However, we do know that altogether it was $28,000. So then our 3% loan will be $28,000 minus whatever we put into the 5% loan, which we're still not sure about. So we can use what we don't put in the 5% loan must be put into the 3% loan. This rate is 0.03. And when we multiply, we have 0.03 times the quantity 28,000 minus X. When I look at my interest then, I have total interest of $1,040 for my total interest together when I add the two loans together with their interest. So the interest of the 5% loan plus the interest of the 3% loan has to equal 1,040. We'll go ahead and distribute our 3/100ths so that we have 5/100ths x plus 840 minus 3/100ths x equals 1040. Combine like terms, subtract 840 from both sides, and when we divide by 2/100ths, we have 2,000 divided by 2, especially if you were going to do that, or just 10,000. That means that since x represents the amount of the money that we put into the 5% loan, I can find that the amount that we put in the 3% loan by taking 28,000 minus 10,000, or 18,000. We've now found that Demarion borrowed $10,000 at the 5% interest and then 18,000 at the 3% interest rate. In December 2009, a solar energy farm was completed at the Denver International Airport. More than 9,200 rectangular solar panels were installed. A solar panel, or photovoltaic panel, converts sunlight into electricity. The length of a panel is 13.6 inches less than twice the width, and we have a perimeter that is 207.4 inches. Let's find the length and width of a panel. So I'm going to set up a rectangle. We don't know anything about the width, but we do know that our length is in terms of width. We know that our length is 13.6 inches less than 2 times however wide our width is. We also know that the distance all the way around our rectangle is 207.4 inches. I also know that the perimeter formula is 2 times length times or plus 2 times W. I'm going to set this up then as 207.4 is equal to 2 times our length, 2 times 2W minus 13.6, plus 2 times our width. When I distribute then, I have 207.4 equals 4W minus 27.2 plus 2W. Combine like terms, we have 207.4 equals 6W minus 27.2. Adding 27.2 to both sides gives us 234.6, which equals 6W. And then finally dividing by 6 gives us 39.1, which is our W. So now that I know what our width is at 39.1, I can then substitute 39.1 into our length of 2 times 39.1 minus 13.6, so that our length has to be 64.6. So if our length is 64.6 and that is 13.6 less than twice the width of 39.1, I find then that it does come out and check out our perimeter when I multiply and add again. So finally then, our length of our solar panel is 64.6 inches and its width is 39.1 inches. Metro Taxi charges $2.50 pickup fee and $2 per mile. Grayson's cab fare from the airport to his hotel is $32.50. How many miles did he travel in the car or in the cab? Let's say he traveled 12 miles. Then his fare would be $2.50 to pick up plus $2 times the 12 miles. Multiplying gives us $26.50. A little too low, so for sure he's traveled more than 12 miles. Now we could continue guessing and checking, but we already have a equation nearly set up at this point. We have our pickup fee plus it's $2 per mile times the number of miles with which we're traveling for a total of $32.50 is what we know how much he spent. Let's subtract $2.50 from both sides so that we have 2m equal to 30 and divide by 2, which is 15. So if he travels 15 miles, the mileage charge then is $2 times 15, which is $30. And if we add the pickup fee of $2.50, we see he spent the $32.50. The answer checks itself out, And so we know that he traveled 15 miles in the cab. Zeros of functions. We want to know where our function crosses the x-axis, and this will be important when we begin talking about polynomials. We know that when something crosses the x-axis, our point would be a number and 0. So the y value would be 0. So we would have a number and a 0. That means then if I want to find the zeros, I want to set my equation equal to 0 because I want to know where is y equal to 0. In this case, then I'll add 9 to both sides and divide by 5. So x is equal to 9/5 or 1.8. This is where our graph would cross the x-axis. And this concludes our lesson on lesson 1.5.